Hey y'all, my name is Jennifer Armbruster and I will be discussing the fourth public lecture, The Physics of Breakfast. This lecture was given by Peter Yunker, an assistant professor within the Georgia Tech School of Physics. His research focuses on soft matter physics, making him a soft matter physicist. This lecture focuses on three aspects of breakfast and how they relate to physics: coffee, scrambled eggs, and cereal. The first topic that we will be discussing is coffee. So when coffee spills, it forms dark rings, meaning that there is a darker circle around the edges and it's lighter in the middle. In addition to coffee forming dark rings when they spill, most other liquids create the same ring effect. But it's only been within the past 20 years that we've actually started to be able to understand what causes this dark ring effect. So coffee is basically just oils and small molecules from the coffee bean suspended in water, making it a solution. But as we all know, oil and water don't mix. So in order to better understand the property of coffee, Dr. Yunker created an experiment in which he suspended colloidal particles. He modeled coffee with a colloid of suspended tiny particles in water so that he could see how they flow and move around with a microscope. He dropped the suspension on a slide and let it dry. It then formed a coffee ring. He took a video of all this happening, and after all the colloidal particles are pushed from the middle, they drop off the edge. So this occurs because of surface tension, and this is minimizing surface tension. Adhesion plus cohesion causes a spherical cap formed by liquid on the surface. As the drop dries, the liquid evaporates. The edges of the original drop are basically pinned in place and don't move as the drop dried. The drop flattens until the last stage when the edges unpin. Surface tension acts against this fact, and that the edges should evaporate faster since they are thinner, which avoids the fried egg shape. Because of this, and as the drop dries, molecules are pushed from the center to the edges, hence how we get the coffee ring. So this can be applied to many different areas. For example, in printing, we really want to avoid this effect. However, understanding this effect has led to advances in malaria testing as well as Alzheimer's test. So the next part of breakfast we're going to discuss is scrambled eggs. So water evaporates as the eggs harden even though they're liquid, but why does this occur? They used a fancy machine called the Universal Testing Machine to answer the age-old questions. Are raw eggs actually a liquid? So the creep test distinguishes between solid-like and liquid-like materials. They tested raw eggs versus scrambled eggs to answer the question, are scrambled eggs elastic? For scrambled eggs, the max force plateaus with time, but raw eggs, it drops down to 0, basically meaning that scrambled eggs are more like a solid and raw eggs are more like a liquid. And the reason for this is because eggs are a protein suspension. So proteins have hydrophilic and hydrophobic regions, which causes protein folding. Cooking the egg results in proteins forming long elastic strands and makes them into a solid. The temperature necessary to denature an egg is less than the boiling point, so you should cook them below boiling in order to keep the water from evaporating and making your scrambled eggs extremely dry. The last aspect of breakfast that we're going to discuss is Cheerios clumping. So why do your last few pieces of cereal end up sitting next to each other? Well, this is from adhesion, which creates a meniscus. Cheerios are less dense than milk, and the meniscus on a Cheerio slopes upwards towards it. Cheerios are attracted to each other as they decrease their potential energy when they come together. Basically, when two cereal pieces bump into each other, they climb on the surface of each other's meniscuses and stay sitting next to each other. So that basically sums up the entire lecture. And after attending this lecture and eating my cereal on Wednesday morning, I couldn't help but watch my chocolate-flavored Cheerios bump into each other. Except this time, instead of just looking at them, I thought about their decrease in potential energy. So after attending this lecture, I learned that the coffee ring effect has helped improve testing for malaria and Alzheimer's, that cooking eggs below boiling will allow them to be fluffier and not as dry. Who knew I would get a cooking lesson out of this lecture? And that Cheerios decrease potential energy when they swim together. Thank you for listening, and I hope you enjoyed learning all about physics in relation to your breakfast.